So in this video, we'll be looking at the example of a ball flying through the air in front of a grid. We have a strobe light set up so that we can get snapshots in time of the ball's position as it's moving through the course of its flight. One thing you may notice is that the ball's position is moving in both the X and the Y direction. So if we call the upwards direction Y and the horizontal direction X, we are moving in both the up and down and the side to side. And so this is different than what we've dealt with in the past, where we've had motion only in the Y direction, which we've dealt with from objects falling, or motion solely in the X direction, where we've dealt with people walking or a car driving. And so the plan of attack, what we're going to do today, is to separate this two-dimensional motion in the X and the Y direction, into just looking at a single direction at a time. So we're going to split it up and to look at just the Y direction, which are the diagrams to the left and to the right of the grid, and then just look at motion in the X direction, which will be the diagram at the bottom. And so these types of motion, if we're just looking at the X direction and just looking at the Y direction, we're going to be able to draw off of the knowledge we gained from the previous module and apply it to this situation to try and understand what's happening to the motion in two dimensions. So we're going to start by analyzing the motion in the Y direction. And we're going to begin with the upward motion. And so this will be the green diagram to the left. So what you want to do is you want to grab a ruler and you want to line it up so that it's just touching the bottom of the ball's position. So you draw a line over to the motion diagram, and then what we're going to do is we're going to place our dot on the motion diagram for that position. And then we're going to repeat this process again for the next position. We draw our point again on the motion diagram, and then we're going to do this until we reach the top. And so once you've got the motion diagram for the upward direction filled in, we're going to move over and analyze the downward Y direction. And so that will be to the right of the grid. And we're going to repeat the same process. So we're going to move our ruler just below the point, the top position, and draw that over to the motion diagram axis. And then we're going to repeat that for the next point. We need to fill in our dots where that crosses the motion diagram axis. And then we're going to repeat that until we reach the last position. Have the downward direction filled in, we're going to move and look at the X direction now. And so what you want to do is you want to flip around your ruler so that it's vertical, and then you want to move to the right of the point that you're looking at, and you want to draw your line down to the motion diagram. And then you'll repeat that same process for the next point, and you want to make sure that you fill in point on the motion diagram as well, so that it's just touching to the left of the crossover point on the motion diagram axis. And then you want to fill in for the rest of the points. And so now that you've filled in all the points, hopefully your motion diagram in the X direction looks similar to mine, as well as the upward and downward motion diagrams for the Y direction. Now that we've filled in our three motion diagrams, what we're going to do is we're going to look at each and see if we can gain any insight into what's happening in the X direction and what's happening in the y direction. So let's start by looking at the x direction motion diagram that's at the bottom. One thing that might pop out at you right away is that the spacing between the points is approximately the same. Any differences are probably just small errors associated with how close we placed our ruler. And so from the previous module, when we have constant spacing in a motion diagram, that tells us that we have a constant velocity. And we know that when we have a constant velocity, the acceleration is 0. Because remember, acceleration is the change in velocity over the change in time. So if you have a constant velocity, your velocity isn't changing, so you don't have an acceleration. And so this is going to be an important part of projectile motion, is that for projectile motion, or motion in 2 dimensions, the x direction is going to have a 0 acceleration. And so since it's going to have a 0 acceleration, its velocity is going to be constant. It's not going to be changing over the entire motion. So once you know the velocity at the start, you know it for all the points across the x direction for the projectile motion. So now let's take a look at the y direction, and let's start with the upward motion diagram. We can see that the spacing between the points is getting smaller as we're going up. And so since we're moving in the upward direction, we know that we have a positive velocity. But as we are moving up along the motion diagram, the spacing is getting smaller. So what can we say about the velocity? What's happening to it? It's reducing, or it's getting smaller. And so if the velocity is changing, what can we say about the acceleration? If the velocity is getting smaller, or if we are slowing down, then we know that the acceleration must be in opposite direction of velocity. So we know we must have a negative acceleration. And so this motion diagram looks very similar to the motion diagrams that we've drawn before, where we've thrown a ball up in the air. And so as it goes up and as it's reaching its highest point, it is slowing down until it stops at its maximum point. So now moving over to the downward motion diagram to the right here, we see that the spacing is increasing as we're moving down the motion diagram. So as we're going down, we know that we must have a negative velocity and that it must be increasing since the spacing is getting larger between each point. And so if we have a negative velocity and that velocity is increasing, then we know that we must have an acceleration in the same direction. So we know that we must have an acceleration that is negative. So let's take a look at both the upward and downward motion diagrams and compare the spacing between like points in the y direction. So if we look at the spacing between these points on the upward and then these points on the downward, what we see is that the spacing between those points is the same. So in both the upward and the downward direction, we have the same magnitude of the acceleration. We also know that that acceleration is negative or in the downward direction. So a magnitude that acts the same in both the upward and downward motion and points downward, that means that for projectile motion, the acceleration in the y direction is the acceleration due to gravity, or g. Now that we've analyzed the motion diagrams, we can fill in the blanks. I can tell the horizontal velocity of the object is constant, and the horizontal acceleration is 0 since we don't have a changing velocity. I can tell that the vertical velocity of the object when it's on its way up is decreasing, and the vertical acceleration is negative. I can tell the vertical velocity of the object when it's on its way down is increasing, and the vertical acceleration is negative.